All right, welcome to Chapter 12, Section 4, called Volumes of Prisms and Cylinders. This is for Integrated Math 2 or IM2. So a couple of things that you'll see on your screen here before we get started. So the very first thing you should see is a due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We allow unlimited attempts on homework, tests, and quizzes. The number of questions is just particular to this assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. Partial credit is enabled. So if you answer, one of however many questions are assigned, then you get credit for that one question or however many you answered correctly. Or within a question, if you answer part of it correctly, then you also get partial credit within a question. So it's kind of a twofer there for the meaning on partial credit. Please remember, once you start your homework, you must finish it before you can work on anything else. What that means is once we click start here, down in the bottom right corner, we will see a submit assignment button. That is how we finish our assignments. So we want to make sure that when we're ready to leave the screen, we click submit assignment, because when the program says you can't work on anything else until you finish, meaning you've clicked that button, it means it's going to lock you out of all of your other assignments and even the resources. And the system is attempting to leave this attempt open for you. I know that's funny. It's trying to leave this attempt open for you. Remember, you have unlimited attempts, so you don't need to leave this attempt open. You can come in and try as many times as you would like. So make sure that you click that button so you don't get locked out. It's going to save your place as well, so it's going to know, where your progress was. It's going to pick you back up right where you left off. The other big reason you want to click submit assignment is because it affects the gradebook when you've done that. So your teacher can see what you've been working on, and you can see, the effect it's making in the gradebook as well as your teacher can see it. So two big reasons to click that button. Basically, your account's frozen until you click it. Everything all around. Resources, your other assignments, and the gradebook. Okay. Off to the side here, we have explanation, example, and message center. So explanation tells us that we're going to lose our current question attempt because it's going to give us the solution to this question. So it's not going to give us the solution and then let us come type, the answer in. Example will give you something very similar to what it is you're looking at. So here it's asking us to find the volume of a rectangular prism. So prism is basically a box, three-dimensional, and it can be rectangular or it can be a cube, like actually the one that we're looking at on the other screen. To find the volume of a rectangular prism, we do length times width times height. So length times width is the bottom, the base, the one that's touching the bottom, and then the height is the side going up. So you just multiply the three lengths, length times width times height, and we get our 90 feet cubed. Remember, this represents the number of dimensions, so that's why it's cubed. It's length, width, height. That's 3 dimensions. And once you're good with that, you can close it. You can open it again for another example if you'd like to see one. You can also message your teacher directly from the screen so we know where to come help you because it will attach a picture. All right, so let's go ahead and get started. So we just saw on the example there that volume of a rectangular prism equals length times width times height. And with this one, we can see that it's kind of a special rectangular prism because it's a cube, meaning that all the sides are the same. So the length, the width, and the height are all 4. So all sides measure 4. So in this case, it's 4 times 4 times 4. But if I remember this is just a little trick. If you have a cube, you can just say it's the side cubed. So it's just, another way to remember that. They don't give us the little calculator here. So you can always use a calculator outside of the program, but they expect us to kind of do this without a calculator. So 4 times 4 is 16. 16 times 4 is 64. So it's 64 centimeters cubed. All right. Next, so a company makes wax candles shaped like rectangular prisms. So, it's not necessarily a box, but, maybe it's something along the lines of, I should have dotted that because technically I'm seeing through the candle here by doing that. So something like that, we have our wick maybe sticking out here. This is where the flame would go. I know it's a little bit of a wonky candle, but hey, it's wax, why not? So each candle is 5 centimeters long, 4 centimeters wide, and 11 centimeters tall. If the company used 5,940 centimeters cubed of wax, how many candles did they make? All right, so they're telling us how much they used, and I know the length, width, and height of one candle. So if I know I can calculate the volume of that candle and then figure out, well, if I know the volume of each candle and I know how much they used, figure out how many times can I use the volume of one candle by dividing, right? So I'm going to go length times width times height. So the volume of this one candle is length times width times height. So, and they gave me this guy, so why not? Length times width times height. So I get 220. So every candle uses 220 centimeters cubed of wax. And the company used 5,940. So I'm going to type that, and I want to make sure I type that in first and then hit divide. Oh, and I'm going to have to erase it because I didn't highlight it, so it went off to the side. Like that. So now I can hit equals, and I can make 27 candles with this amount of wax. So there's 27 different times that 220 goes in. All right, so this one's just an application type problem. It's having you calculate volume and use it a little farther than just volume of a single object. I have to use that volume with the next piece of information. All right. Our next one is find the volume of a triangular prism. So be sure to include the correct unit. So this time they're not putting the unit on there for us. It's volume. So it's still going to have kind of a length times width times height idea. It's going to be a little different because of triangles. But whenever we're dealing with volume, it's going to be cubed. I already know it's going to be meters cubed because it's volume. If it's a length, it's meters. If it's an area, that's cubed. If it's a volume, then it's, squared. If it's a volume, then it's cubed. I pointed to the square and said cube. Silly me. So this is one that you would have to click on, most likely, unless you knew this, the formula already for this one. You'd want to click on here to kind of look at the background information and say, okay, well, how do I calculate the area of a triangular prism? A rectangular prism, we did actually this exact same formula. And I'll go like this and say volume equals base times height. Well, the base of a rectangular prism is length times width because it's a square or a rectangle. And that's how I find the area of a square rectangle is length times width. So we're actually going to use that same formula for a triangular prism. Instead of using length times width, though, I'm going to go area equals, it's still base times height, but the base of a triangular prism is triangular. So it's going to be 1/2 base times height, and this is of the triangle. So whatever the triangular base is, I want the base and height of that. And then I also have to multiply by the height of the entire prism. So it's just breaking it down and saying, okay, well, how do I find the area of whatever shape the base is, and I'm going to multiply by the height. We're actually going to use this for every type of prism. And it even applies to pyramids, slightly cones, because we actually do kind of use a base times height idea with cylinders, but we have to account for the missing space there too. So they actually get divided by, instead of just a half, it's different fractions. So we want to make sure we're paying attention to what the base is. All right. So in this one, if I'm looking at the triangle, so I'm going to focus on the triangle first, the base of the triangle is 6, and the height is always the dotted line, or if it's not dotted, we want to look for that perpendicular, but it's usually the dotted line that's perpendicular to the base. So we have the base of 6 and the height of 9 just for the triangle. So I have, whoops, didn't mean to put an extra line there. That 1/2 times 6 times 9, and then the height of the entire prism is 8. So I know there's 2 H's here, can get a little funky. One's the height of the triangle, one's the height of the prism. So just make sure you're paying attention to that. So with this one, I can say 1/2 of 6 is 3, and just kind of reduce that. And then 3 times 9, well, let's see, I can actually do 3 times 9 times 8 is 72. That one's a little bit easier, I think, to multiply by 3 instead of doing 3 times 9 times 8. So I'm kind of trying to group them a little nicer if I can here. So this is 6 and 21. And it's going to be meters cubed. So I get 216 meters cubed. All right. So the next one, we're going to look at a cylinder. So like I said, it's still the same idea. It's the area of the base times the height. And I know this always looks a little funky when I do it, but to kind of visualize that, if we had blocks in here, ooh, that's not a very good line. If we had blocks in here like this going across, so I have 1, 2, 3, let's add another one, 4. So I have 4 blocks going across and 5 going along the front. So this is 5 blocks by 4 blocks. And then each centimeter, it's a cube tall. So it's 1 centimeter by 1 centimeter, each one of these cubes like this. And I can fit 220 of them in here because we worked that out. This one was 220. So if I filled this up, there'd be 220 little centimeter cubes. That's what I'm saying is, when I say a cube unit, is I'm saying a cube that's 1 centimeter by 1 centimeter by 1 centimeter, and I have 220 of them. Same thing here with this triangular prism. I was saying that there's 216 meters cubes, so 1 meter by 1 meter by 1 meter. So those are definitely bigger cubes than the centimeter cubes, but I had 216 of them that would fit in there. So same thing with this cylinder, it's just a little different because it's round, but we still have the base times height. So volume equals base times height, but now the base, remember when I say capital B, that means area of that bottom shape, or basically the two shapes that are the same. That's kind of the other way we can think of it, the two parallel sides when we're talking about a prism. So I have circles here, so that's pi r squared. That's how I find the area of the circle. And then I have to multiply by the height of the prism. So I'm going to go volume equals, and instead of pi, they asked us to do 3.14. So 3.14 times 5.5 squared, because that's our radius here. And they told us that up here also. Sorry, I didn't read it out loud. The radius of a cylindrical water tank is 5.5 feet, and its height is 9 feet. What is the volume of the tank? So I kind of jumped in using the picture here. Always read the question just to make sure that you know what it's asking you to do. I knew what it was asking us to do just because of the notes that we had done in class, so I kind of jumped ahead a little bit, and I should slow down and make sure I still teach that. Read the question. And then we also want to multiply by the height, 9, sorry. So kind of jumping around there in my conversation. So I have pi times r squared times the height. So volume equals, and they gave us another crack at the calculator here. So 3.14 times 5.5. I have to hit this button for squared and put the 2 in. And then times 9 equals. And it told you to round your answer to the nearest whole number. So it knows that we're not going to end up with a whole number, but it wants us to round it down. And I'm going to make sure really quick that I didn't hit a funny button there. I don't think I did. I could have hit undo also just to make sure, but nope. Okay, so we're good. So I'm going to round off to the nearest whole number. So that means that my whole number is 4. I just need to make sure the next number, the rounding number, is that 5 or bigger or 4 or smaller. So it's 5 or bigger. So this is going to round up to a 5. So 855. And then I do need to make sure I also choose my correct unit. Since it's volume, I know it's going to be cubed. Make sure, I think they're always going to use the same unit. I haven't really seen them mix units and make you choose, like, is it meters, feet, inches? You know, it's usually this idea where it's the same type of unit. You just have to choose the correct one as far as, is it length, is it area, is it volume for squared or cubed. So just make sure you're paying attention. If it's volume, it's going to be cubed. All right. A company rents water tanks shaped like cylinders. Each tank has a radius of 4 feet and a height of 3 feet. The cost is $5 per cubic foot. How much does it cost to rent one water tank? So they want us to take volume. We just learned how to calculate the volume, and then take that a step further. Apply that knowledge. How could I use that knowledge? So I want to rent a water tank. It holds so much water, which I can calculate using the volume formula. I can figure out how much water can that tank hold. And then I know that for every cubic foot that it holds, remember the little cubic thing, where it's a cube. This one would be 1 foot by 1 foot by 1 foot. Every single cube that size is $5. So I can figure out how many cubes are in there by using some division, right? All right, so we're going to do volume equals the base. Oh, and they asked us 3.14, so I'll change that. I was going to write pi, but 3.14 times the radius, which they told us was 4 feet, times the height of the cylinder, which is 3 feet. So let's come over here and we're going to go 3.14 times 4 squared times 3. All right, so the volume of the tank is 150 and 7/200 cubic feet, or feet cubed. So that's how much water this tank can hold. Every cubic foot is $5. So I want to take this and divide by 5. I want to know, divide by 5. What am I doing? Multiply by 5. Because every single one of these cubic feet is $5. It's going to cost me $5 to hold each one. So each, I want to multiply. So it's going to cost me $753.60 to hold that much water. I'm going to put a 0 on the end. I don't believe that Alex would mark you wrong without the 0, but just proper to put the 0 there when we're talking about money. All right. So a lot of these volume ones, we're going to have an introduction to how to calculate it and then some kind of application for it. So just watch out for that and just kind of think through, how do I use what I just learned and apply it to this question? All right, that was section 4. I will see you in section 5.